Good morning, students. So today we will discuss few more cases. The first case is the motion of two bodies in contact. So here we have placed two bodies. The body of mass of the first body is m1 and mass of the second body is m2. Here m2 is greater than m1. Okay, and we have applied a external force F. Now if you apply an external force, that means ultimately these two bodies, they will move in which direction? They will move in this direction, positive x direction. That means they will have some acceleration in positive x direction. Correct? They will move means they will have some acceleration in this direction. Now we have to calculate its acceleration and contact forces. Now first we have to draw the free body diagram. Now so if we apply a external force on the first body, so what will happen? The first body, it will push the second body. Okay. So since they are in contact, so that means this force is called contact forces. So this first body will apply some force, contact force on the second body. This force is suppose S F. So as a reaction, this second body, it will also apply the same amount of force on the first body. Okay, this also F. These two forces are action reaction pairs. That means they are equal and opposite forces. This F and F, they are equal and opposite forces. So let us draw the free body diagram. So how many forces are acting on the body? First body. So obviously gravity is attracting the first body with m1g force, and there is a reaction. There is a normal force on this body also. That force is r1, normal force. This force is due to the ground. Now we have applied F force. This force is external force on the first body, and there is a reaction force also on this first body due to the second body, and this force is small f. Okay, so that means the total four forces are acting on this body. So we can write that first equation will be r1 is equals to m1 into g. Correct? But this equation, we don't need this equation right now. The second equation will be just concentrate carefully that. So here F is not equals to F. Why? Because this body, first body, it has some acceleration in positive x direction. So that means this first body, it is not in equilibrium position. So you cannot write F is equals to F. So you can write this equation only in the condition of equilibrium. So this body is not equilibrium. So this body has some acceleration in positive x direction. Now first tell me which force is greater. This F is greater, or this small f is greater. Obviously this F, capital F, external force is greater. Why? Because ultimately this body, it is moving in the positive x direction. So that means this F, external force, it is greater than F, small f. So you can write that F minus F is equals to force is equals to mass into acceleration. Net force is equals to mass into acceleration. Mass of the body is m1, acceleration is a. Correct? Force is equals to net force is equals to mass and acceleration. Why minus? Because this capital F and small f, these two forces are they are acting in the opposite direction. So this is our first equation. F minus F is equals to m1 into a. Now free body diagram of the second body. So obviously gravity is also attracting this body with m2g force, and there is a reaction force or normal force on this m2 body by the ground, and that force is r2, and that is positive y direction. And look, this external force, it is not acting on the m2. This force is acting on the m1 only. So that's why we have so that's why we have not drawn this one. So which force is acting on this m2 body? So this contact force small f, it is acting on this m2 body. This capital F is not acting on the m2. Okay, capital F is only acting on the m1, but the contact force is acting on this m2 small f. So you can write the first equation will be r2 will be m2g. Why? Because these two forces are in equilibrium. R2 and M2G, these two forces are equilibrium, because this body is not going upward direction or downward direction. That's why you can write this one. Okay. And here, but here in the horizontal direction, only in the left side you have F. Okay, so you cannot write F is equals to 0, but because this body is not equilibrium again, because this body has some acceleration in positive x direction, so you can write that force is equals to mass into acceleration. So F is equals to m2, mass is the m2, acceleration is a. Okay, so this is our second equation. And the acceleration, so acceleration is same for both the bodies. Okay, because since they are in contact, so F is equals to m2a. So if you put the value of equation number 2, that means the F is equals to m2a. If you put the value of small f in the first equation, the first equation will become F minus value of small f is m2a is equals to m1a, or F is equals to m1a plus m2a. So if you take common m1, the equation it will become F is equals to m1 plus m2 into a. So this is the value of external force, m1 plus m2 into a. Now what is the value of acceleration? So if we put the value of, okay, so from this equation you can write cross multiply, you can write that a is equals to F by m1 plus m2. So this is the equation of acceleration. So you first remember that you don't have to remember these equations. Okay, in numericals you have to derive the equations. Okay, first you have to draw the free body diagram, then you have to derive this equation. So don't remember or try to memorize these equations. So okay, so we have find out the value of acceleration a is equals to F by m1 plus m2. Now if you put the value of a in equation number 2, that is F is equals to m2 into a, and the value of a is how much? m2. We have derived that F into F divided by m1 plus m2. So this is the equation of contact force. F is equals to m2F divided by m1 plus m2. Correct? Now if so now if you applied the force, external force on m2, not in m1, then your equation will be this one. Okay, you can derive by the previous process. Now second case is body is connected by strings and placed on horizontal plane. Okay, so here we have two bodies again, m1 and m2. A mass of the m2 is greater than m1. Correct? And the two bodies m1 and m2, they are connected with a thread or a string. Okay, and we assume that this thread on a or the string, it is the massless. Okay, because if it is a mass, obviously in reality it has some mass, then you have to calculate for its mass also. So we assume that this thread or string, it is massless, and we assume one more thing, there is no frictional force between the bodies and the ground. Correct? Because in the, if you assume that there is a friction, obviously there is a friction in reality, because then you have to calculate for the friction also. So here we have only discussing about the most simplest cases. So in the previous case also we considered that there was no friction. Okay, this is a frictionless surface. So they are connected to a thread, and we are applying a force, external force in this direction. So if you apply external force, so ultimately these two bodies, combination of these two bodies m1 and m2, ultimately they will move in this direction, positive x-axis. That means in this direction they will have some acceleration a. Okay, now the tension force. So if due to this external force, okay, so since these two bodies are connected with thread, so m2 will try to pull this m1 in this direction, and m1, since it is at rest, it will try to pull m2 in this direction. Now look at the tension forces. M2, it will feel that the body m2, suppose if you are body m2, so then you will feel that the m1 is trying to pull you in this direction. So that means tension force is in this direction, negative x-axis, correct. But you, for M1 will feel that M2 is trying to pull it in this direction, positive x direction. So that means for M1 the tension force in is along the positive x direction, but for M2 the tension force is along the negative x direction. So let us draw the free body diagram. Okay, for M1, gravity is attracting it with M1G force, and there is a normal force R1. This force is due to the ground, and the tension force due to M2 is in this direction, positive x-axis. So you can write that R1, first equation is R1 is equals to M1G, because these two forces are equilibrium. Okay, R1 and M1G, they are in equilibrium. So R1 is equals to M1G, but this equation is not needed here. We will need the second equation only. So second equation in the horizontal axis. So in horizontal axis there is only one force T, but the body is moving in this direction also with acceleration a. So you can write T is equals to M1a. Force is equals to mass into acceleration. So here tension force is equals to mass into acceleration. Now free body diagram for second body. So gravity is attracting the second body with M2G force, and there is a reaction force or normal force R2 due to the ground. Now we have applied the F force, external force F, in this positive along the positive x direction, and there is a tension force due to M1 which is along the negative x direction. So there again there will be two equations. First equation will be R2 is equals to M2G, but this equation is not needed here. So why I am deriving this equation? It is not needed because in your questions you, okay, so there the questions can be defined from so in your question you might needed this type of these equations, so that's why I am deriving. So just understand how to draw the free body diagram, and how to derive the equations. Okay, from here how to derive the equations. So don't try to memorize the formulas. Okay, so these are not the formulas. So R2G is equals to M1G, and the second equation will be, okay, so body is this body has an acceleration in positive x direction, and which force is greater? Obviously this external force F is greater than tension force T, because ultimately this body is moving in the direction of external force with the acceleration A. So you can write that F minus T is equals to M2A. So this is your second equation. F minus T is equals to M2A. Okay, so from here you can write that. Okay, so adding 1 and 2, so if you add these two equations, T will cut. So you can write that F is equals to M1A plus M2A. If you take common A, so it will be M1, F is equals to M1 plus M2. From here you can write that cross multiply. You can write that, I hope you know how to cross multiply. A is equals to F divided by M1 plus M2. Okay, so this is the acceleration of the system. Then tension. So from the first equation, T is equals to M1A. So in place of T1, if you put the value of A, T is equals to M1, and the value of A we just derive F divided by M1 plus M2. Oh sorry, correct. T is equals to M1. So this is your equation. T is equals to M1 in M1F into M1 plus M2. Correct. So this equation is also correct. M2F into. So this is M2. Look, there is a difference. I have derived in terms of M1, and this in your book it is derived in terms of M2. That means they use the second equation. So the third case is the pulley system. So here two bodies, body A and body B, the mass of the body is M1 and the mass of the body 2 is M2, and here it is given that M1 is greater than M2. okay, and they are connected to a thread or a string, okay. So in this system, so if this body A has the greater mass, M1 is, if M1 is greater than M2, then what will happen? Obviously, M1 is it will go downward direction, okay, because it has greater mass. So that means this body is this system is not in equilibrium. So this M1 it will go downward direction, and M2 it will go in upward direction, because they are connected with the same string or thread. And remember one more thing: if a body is connected, if two bodies are connected with the same string or thread, then the tension in this thread or the string will be same. Tension is same in this same thread or string. If I consider this thread, so this is a different thread, so tension in this thread or this string it will be different. So I'll write here it is T1 or T2, okay. So for the same thread or for the same string, the tension will be same. So let's draw the fluid body diagram. So how many forces are acting on the body A? So two forces. So it will feel the first body A, it will feel that this it will feel the tension is along in this upward direction, okay, because it will feel that M2 is trying to pull it in upward direction. Now similarly, M2, this body, second body, it will feel that this M1 it is trying to pull it in upward direction. So it will feel that the tension is in upward direction. For that means for both the bodies, the tension is along the upward direction. So M1G gravity is attracting the first body with M1G force, and the tension is along the upward direction. So here, so now which force is greater? M1G is greater than T, or T is greater than M1? So for body A, M1G is greater than T. Why? Because ultimately this body is going downward direction. That means it has some acceleration in downward direction. So that means M1G is greater than T. So from here you can write that M1G minus T is equals to A. M1G minus T is equals to minus T is equals force equals to mass into acceleration. So mass is M1, acceleration is A. So this is your first equation. So second equation. So for in the second body, there is again two forces are acting on this body. Gravity is attracting it with M2G force, and there is a tension force in upward direction. And here remember, look, now which force is greater? Here the tension force is greater than M2G. Why? Because this body it is going upward direction. It is going upward direction. That means the tension force is greater than M2G. So for this one, you can write T minus M2G, not M1G minus T. T minus M2G, because T is greater than M2G, is equals to force is equals to mass into acceleration. Mass is equals to M2, acceleration is A. So this is your equation number 2. So using these two equations, we can derive the equation for acceleration and tension. So M1G minus T is equals to M1A, and T minus M2G is equals to M2A. Now if you add these two equations, so T and T, positive and negative, it will cut. So your equation will be M1G minus M2G is equals to M1A plus M2A. Now take G as common. G into M1, so M1 minus M2 is equals to A into M1 plus M2. So if you cross multiply, so this equation I am talking about, this equation. So if you cross multiply, A is equals to M1 minus M2 into G divided by M1 plus M2. So value of acceleration is this. Now if you put the value of acceleration in the first equation, okay, so the first equation was M1G minus T is equals to M1A. So if you take T in the right side, M1A in the left side, so this equation will become M1G minus M1A is equals to T. Now what is the value of A? Value of A, so you can write T is equals to M1G minus M1. What value of A we just derived, that M1 minus M2 divided by M1 plus M2 into G, correct? So I'm talking about this equation. So this in these two equations you can see that M1G is common. Here M1G and here M1 into G. So you can take common m1g. So this equation it will become m1g into 1 minus m1 minus m2 divided by m1 plus m2. So ultimately T is equals to 2m1 m2 divided by m1 plus m2 into g. Correct. So here I have to calculate. You have to, so from this equation T is equals to how much? T is equals to, so you have to, okay, now so if you now you have to subtract. So T is equals to m1g into, so 1 minus m1 plus m2. Okay, so 1 into m1 plus m2 is m1 plus m2 minus m1 minus m2, m1 minus minus plus plus m2. So m1 cut. Okay, so that means m1g into 2 m2 divided by m1 plus m2. Now multiply, you will get this equation. Final this equation. Now last question. Now so not question. The last topic, two bodies connected by string, one body placed on the smooth surface. Okay. So here two bodies are connected with a string. So here it is given that this body it has some acceleration in downward direction. Okay. So first we have to draw the free body diagram. So there are two forces acting on the body A, that is the m1g in downward direction and tension in upward direction. So obviously you can write that an acceleration, this body has some acceleration in downward direction. So you can write that. So that means m1g is greater than t. So you can write m1g minus t is equals to m1 into force is equals to mass into acceleration. Now for second body, there is three forces are acting on this body. The first, gravity is attracting it in downward direction with m2g. And there is a normal force, normal reaction force R due to the ground, and the tension force is also acting on this body, okay, in positive x-axis. Okay, so for you can write that now R and m1 they are in equilibrium, so you can write that R is equals to m2g, but we don't need this equation right now. Second equation is T is equals to m2 into a, correct, because this body has some acceleration in this direction. T is equals to m2a. So these two equations we have derived. So in using these two equation, if you put the value of t, what is the value of t? m2a in the first equation, you will get these two equations. So m1g minus what is the value of t? m2a. m2a is equals to m1a. So or m1g is equals to m1a plus m2a. So take common a. So m1g is equals to m1 plus m2. Okay, so cross multiply, you will get a is equals to m1g divided by m1 plus m2, the first equation. Now put the value of a in this second equation. T is equals to m2 and the value of a is m1g divided by m1 plus m2. You will get this equation. So I will give some problems based on this one, second case and the third case. Okay, and you have to solve. So thank you for today.